Hi everyone, we're going to sketch the curve whose parametric equations are given, show the orientation, and identify the requested point. So they want the rightmost point. So that means whatever goes with this 10, this is going to be the rightmost point for your x. This is your x value. And we're going to identify the requested point, justify the point by analyzing the appropriate derivative. All right, so let's go ahead and graph this. To save time, I went ahead and used the calculator and plotted some values. This just looks like a line, so we can't have 0 because that's undefined. So I did put like a 0.0001 for a value. So at negative 0.53, so 1, 2, 3, 4, 5, we're way down here somewhere. So just know this goes down here because this doesn't work very good. Now at 2.3, which is about here, that's when t is 2, and I skipped because this looks linear. This is pretty much a line. I just did the even ones. So at 2, our x is 2. Well, at t is 2, we have 2.3. And then 2.7. So it goes right about here. And at 3, we're at 4. So this is 1, 2, 3, 4. And at, what was this? This was at 2.33. We're at 4. Okay. And at 3.4, we're at 4.9, which is close to 5. You can kind of see what's going on here. This is pretty linear. So basically, your graph looks something like this. And then we have to stop at 10, because that's going to be your rightmost point. So the main thing we need to look at is this one. So we're looking at 3.91, which is close to 4. And that goes to 6, which is here. So we stop right there. All right, so I did too much there. Now this stops down here, somewhere down here, but my grid here doesn't show it. But this is the point we want, the rightmost point. All right, since we're talking about the right, that means we're going to take the derivative of the right. So basically, that means it's going to be ln of, we have t as 10, so that's going to be ln of 50, which goes with ln of 400. That's your rightmost point, which we already got. This was 3.912, and then we had 5.991. So that's what we're going to look at. And let's see what we have. We're going to maximize our x because we're talking about the rightmost point. So you're going to maximize x as a function of t. So you're going to take the derivative of x with respect to t. Now this just equals the derivative of this is just 1 divided by 5t times 5, which equals 1 divided by t. And this is positive for all t that is greater than 0. So there's an endpoint maximum at t equals 10, whereby your x, y equals ln of 50 for your x, and your y is ln of 400. All right. Thank you. Have a nice day. Bye-bye.